Configuration of certain practical solar thermal collectors. So once again we come across the topic which I have discussed right now, the liquid flat plate collector and air flat plate collector, and we discuss here in detail about glass also, sorry, glaze. So not in this. Next we have, that is materials used for different parts of a solar collector. So there we discuss. So just we'll understand what is a glazed, unglazed collector. Different types of collectors are given. So we'll see how the configuration for a practical solar thermal system will be present here. So first one, already we know that solar flat plate collector. So it is a common, most common used solar flat plate collector for solar water heating system in homes as well as a solar space heating. So solar water heating is my first one, that is a liquid, and air heating will be used for my space heating. So this will be typically like a insulated metal box. Usually this type of flat plate collector will be having like a metal box with a glass or a plastic cover, so called as a glazing, and a dark color observer plate. So where it will be with a black paint so that it can observe the solar radiation. So that will be in terms of your liquid as well as a air flat plate air collector. And apart from this, the most common air and liquid based solar collectors that are from point number 2 to 8. So these are the most common liquid as well as air solar thermal collector. That is first one, glazed flat plate collector, unglazed flat plate solar collector, unglazed pre-faulted plate collector, and back pass, batch flat plate collector with flat reflector, and evacuated tube collector, that is nothing but vacuum tube collector. So we will discuss one by one here. So that is the second one, we will take the glazed flat plate collector. So this is similar to the figure which is already shown here, the first figure with respect to flat plate collector. Yeah, it will be similarly in this fashion, where you can see the glazing is shown over there. So here, this is very commonly and available for a liquid base as well as a air base, both. It can be application of liquid as well as a air. We make use of a glazing on both type of a collector. These collectors are better suited for a modern temperature application, where if temperature is required within the range of 30 to 70 degree, and for applications like during winter month, where we want to heat room space, or if you want water to be heat. So basically 32 degree temperature will be application for in a winter month. And in a liquid base collector are most commonly used to heat a domestic and commercial hot water. It could be buildings, or it could be your swimming pools, indoor swimming pools, etc. And your air based collectors are used for heating, once again, building, ventilation air, and crop drying also. So in India they are not using crop drying so much here, so but in foreign countries they are using for a crop drying. So like crop could be your coffee seeds, or your tea or tobacco. So these seeds they make use to dry this crop using the solar crop drying system. And the third one, that is the unglazed flat plate solar collector. So the name itself saying it is an unglazed flat plate collector for a large portion of the collector installed per year of any type of solar collector in the many country. So if you take any country, this type of solar collector is having with a large portion, and they are installed per every year, and they are easily suited for that atmosphere throughout the country. Because why it is so popular? Because they are not insulated, first point, and these collectors are best suited for low temperature application. Even though if it is a cloudy area, and even though the temperature is very less over there, I can make use of this application, where the temperature demand will be below 30 degree. If it is a 30 degree, less than 30 degree application also, I can make use over there. And in the primary market for this unglazed flat plate collector, we make use in a primary market like heating outdoor swimming pools, uh, and also like farming operations, where we can make use of a water over there, and also like fishing farming. So for that also they may use water, and preheating water for car washers, and once again swimming pools is included here. So these are some primary market application which is used for a unglazed flat plate solar collectors. Sometimes they use for summer camps also, where the remote area where we want to heat the water, we make use of that, this application. So what is the material used to made this, or how it is made up of? So these unglazed flat plate collector are usually made up of black plastic. It will be made up of a very thin black plastic that has been stabilized to withstand UV rays. So because I am not using any glaze, so usually glaze will be used on the top of the flat plate collector to protect from UV rays, so that and also mechanical damages. So if directly the UV falls on that, it may damage my entire device in the long run. So here they are using unglazed, but to overcome that they are using a black plastic, a thin black plastic, which will stabilize to withstand this UV rays. Since the collector is not having a glaze, the last portion of the sun energy is absorbed. Directly it falls on the observer, because there is no other medium in between that. It will fall directly on the observer, and large portion of the energy will be absorbed from the solar radiation here. And here, so this type of solar flat plate collector can be used during night also, as well as if the hot and windy outside. So during night, if the temperature is high, because it could be your air also, it could be your liquid also. During night time, what happen? We may have a air which transfers some amount of heat present over there. It can generate a heat air over there for a space heating. And if it is very hot and windy outside also, in that case also we can generate a solar application from this unglazed flat plate collector. So that's the reason it is very popularly used, because it will be suited for many application with a low temperature. So the fourth one, unglazed pre-coated plat collector. So it is similar to the above one. The only change will be, so where the observer will be having a sheet with a holes, which has a very small holes of a 2 to 4 centimeters. Right? So where instead of it can easily the liquid or the air can flow within that. So basically this is used for a air type of flat plate collector, where air can easily pass without any obstacles. So because the entire area of the observer will be having a small holes of 2 to 4 centimeter. So when the air passes through these holes, the collector will collect the heat which is present over there, and it will be used for your in the buildings preheat fresh ventilation air. So for ventilation and for space heating, we make use of this air, the hot air which is obtained from the hole which has been passed. And the efficiency is typically high because there is no obstacle, and air can easily flow from the holes, and whatever the heat present from the observer, it can pass through the for a particular application. The efficiency is very high as compared to the other one. This system can be very costly, and especially when they replace a conventional building, because only the incremental cost need to be compared with the energy saving. It is higher cost, but when you look at that, what is the initial cost I am investing, later whether it is a running cost is involved or not, based on that we try to compare the energy saving here. The energy saving is higher side because it doesn't involve so much of running cost here. The initial cost is high. So application, once again the same, we make use for a building ventilation, air heating, or we say space heating also. And other application of this unglazed is like as I mentioned, in South America and Asia, they use for drying the crops like tea or coffee seeds and tobacco. So for this application they make use this method. The next one is back pass solar collector. So it is once again air base. It's not a liquid, it's a air base solar collector. So the design is very, very simple. They often have a weight very less compared to the other collector, uh, and because it doesn't have any piping over here, so because of that reason the weight is very, very less. So in the, if you compare to the previous liquid flat bed collector where the pipes will be present on the observer, it could be soldered also, soldering will be done or welding will be done. So whereas in this case it doesn't consist of any pipes, so hence we can say the weight is very, very less here. And the air based collector doesn't have freezing or boiling problem. So in the previous case, if you're passing any fluid over there, there is chances of the temperature will rise over there because of a boiling problem, and sometimes due to the extreme temperature within the liquid present within the pipes, it may get freeze also. So that is that problem is also not present in the back pass solar collector. The simple design of this type of back pass collector is single pass open collector. So at one side the air will pass and the other side will be open. So that is called as a single pass open collector. These type of collectors are coated with a glaze, can also be used to heat air for a space heating. We can make use of a glaze also, that is also possible with glaze and without glaze. The next one is batch flat plate thermal collector. So in the if you go back to the conventional days, so we used to paint a black paint for a container and we try to heat the water from the solar. So the same application, the same method is involved in the today's primary market, that is for application like residential water heating in a warm countries, and the modern batch collectors is having a glaze that is similar to the one which you use for a flat bed collector, which could be your reflector or a concentrator type. So which has a reflector and which has a concentrator, so that we can concentrate entire energy at a tank surface, which will be like a black painted once again, or it could be something insulation type where we can avoid the heat losses over there. So because of the storage of tank, the solar observer act as a single unit in this case, and there is no need of other component. So one more advantage here is we make use of a solar tank and a solar observer within a one unit. So other components will be not required here. And the next one is flat bed collector with a flat reflector. So the name itself saying we are using a reflectors here. So it is found that by using these reflectors, additionally we can increase the temperature up to 44 degrees Celsius in the winter and 15 degree in the summer condition. We can enhance the solar energy which is obtained from this type of collectors by adding a flat reflector. So the diagram for that it is not given here. So I will try to show that. It will be once again the similar flat plate collector which is seen in the first case. So only thing, it has a reflectors. Apart from that, I will try to draw here. It will be in this fashion. It will place in one angle. So these are my flat plate collectors, and within that we have these pipes where it can flow liquid on the observer, and the solar radiation will fall in this way. They make use of additional reflectors like this. I will try to write another color. So reflectors will be present in this way. Just they're making an angle so that whenever the solar radiation fall the outside also, it can reflect back to my collector. So this is how the arrangement will be done. It is similar to the flat plate collector with an additional reflector. So by doing this, they are increasing the temperature to 44% in a winter and 15% in a summer condition. And the variant of the collector which are already seen in the, types. So the same case. So only thing we try to concentrate the temperature on the observer plate. Further, in this case, we have one more type that is called as a evacuated tube collector. as I mentioned, so where it is a vacuum tube, we can say, where with the vacuum will be there. So